right, guys, thanks for staying. My name is Haischel Dabian. I'm the co-founder of CRUD. And like Ricardo said, we're here because we won the blockchain hackathon, where we participated in the machine-to-machine economy. And the idea was to create a very futuristic solution to problems of today. So a little bit about us. A little bit about us. So we're a startup based in Amsterdam. We're like 12 guys, and what we do is we help companies from the idea phase to actually implementing a prototype. And that's what we do. We've been working with some major clients, such as FedEx, Shell, KLM, implementing all kinds of solutions using blockchain technology. And for the hackathon, the problem we tackled was climate change. As we all may know, the climate is changing. It's causing a lot of drought, for example, in California, or even closer to here in South Africa. There's a lot of problems with drought, and they almost reach day zero, which means that they close the tap water. So it's a big problem all around the world. Also, hurricanes are getting a lot bigger. As we've seen in the past year, they're getting a lot stronger. We've had Irma, Maria, that devastated Puerto Rico. St. Martin has been hit as well, and it's just becoming a bigger and bigger issue each and every year. And Greenland is actually getting green, which is a bad thing. So we have droughts, heavier hurricanes, and all of the ice is melting all over the world. And we have these companies that are trying to actually take a reactive approach to the problem, which is helping aid these countries getting back to pace. And it's a big problem everywhere. So what do we need for this? So our idea was to build an ecosystem of machines that communicate with one another. So we can have drones flying around during research and exploration to have a proactive approach to the problem, help predicting whether the impact of the problems that we're facing due to climate change. Search and rescue, we can even have these machines scouring area, trying to find people and getting them out of their problems. And even rebuilding. In the future, we can have drones that can reallocate resources and actually start building camps and afterwards cities. So that's our solution is called Drex. It's a decentralized hive mind. You can think of it as an ecosystem of all of these machines. So you have energy stations which charge all of the drones. You have drones during search, drones during rescue. You can also have repair stations. So it's like an entire ecosystem where you don't need any human interaction. All of these machines work together, repairing themselves, creating 3D printing new drones. So in a whole ecosystem of the future. So Dan will take over of what we actually build.
Yeah, we did try to retrofit drones with running a full node of BigchainDB. And for that, there's a lot of advantages using BigChain. The fact that Troy covered is the BigChain actually allows you to query assets. This is really important because if you want to do and track a change over time for very large objects, you have to check every transaction. On BigChain, you can do it by just checking an asset, and they put it even further. They have object relational models on BigChain. And this is really easy because now we can basically create an asset and we can track it for time without having to actually post transactions in the code. This all happens in the backend. And in order to do that, on 2.0, to my knowledge, again, this is full copies. Each drone has a full copy of its Mongo database. So you can do local queries. You no longer have to query the entire network, which really helps a lot because now we have a drone that has full knowledge of the area around it because it has the data of all the other drones. And we actually got it running because we swapped a bit of code on deploying BigChain, Tendermint, and Mongo on ARM64 devices. So your standard laptop would actually run on Intel x86 or AMD 64, which is the standard instruction set for computers. This runs on ARM64. It's a bit different, but it actually is slightly compatible, so it all worked in the end fine. For this, we actually had to use the object relational model, which seems to be not switching. Yeah, it is. Here you go. And Witzel is going to explain it better.
So about the object relational model, what it is creating an object in your BigchainDB database. It's a very database-like structure. You see it in every database. You can create an object and append stuff to this. We used it on BigchainDB 2.0. To be honest, when we started the hackathon, it wasn't even released on 2.0. On the hackathon, with the help of the guys of BigchainDB, Jerne mostly, they moved software from 1.3 to 2.0 just for us, so we could use it in our solution, which we used to its full extent. We created 2 different models to help us create this solution. Our first model is the drone model. So we have these drones running on missions. They're completing tasks. They're detecting objects. They're searching for people that need to be rescued. So each drone is its own object. And every action that drone makes, every change that's happening on that drone is appended to that object, which makes us able to not search through the whole BigchainDB database for every single transaction, but we can just query the database for the single object. We get the whole object back, every change it made, can verify everything that it's done, and complete our research with the data it gathered. Together with this, we created a grid model, which is a model of the world itself. Like every drone excavates the world, sees what happens, and they notice changes. They notice people that need rescuing. That's all stored in the grid model and all stored in the BigchainDB database. Everything that's found is appended to this grid model, so the whole world gets stored and changed in the grid model. So this is all based on the CRUD model, which stands for create, retrieve, append, and burn. This is the blockchain implementation of the ORM model for pretty much databases. So here you have the small piece of code for creating a type of object, which just takes the type you want to create. Like I want to create a drone. You give its current status, like, okay, I'm starting my mission now with full batteries. I'm starting at point XY, and I'm flying to some point. So it's just creating objects to add to your missions, to your world, and actually use on your database. So there's also a way to retrieve this object. So instead of searching your whole database for transactions made by this ID of the drone, like going to every transaction, is this a drone I'm looking for? Yes, no, yes, add it to a list. It's just based on one function call. You call this and you get the whole object back with its full list of transactions made, full list of changes, everything it did. Here. So appending changes to objects is also very straightforward. You just give the object like, okay, this mission has this world ID. I want to append a drone to it. I want to give this mission an extra drone because it just got repaired or it just got changed or whatever. So you can add new stuff to this world and it gets added to the list of transactions of this object, appending it to the whole database and getting retrieved when retrieve is called. So the B is strike through because of mainly time constraints during the hackathon. We didn't implement a burn as we didn't really see the need for actually destroying like a drone object or whatever. What burning means is you send it to an empty address. You send it to an empty key pair that's not stored anywhere, so it just gets irretrievable. One use case for this on our solution might be creating, when a mission is done, creating a new object and just storing everything in there without having to search from, okay, this mission has this drone, so give me that drone. Just store every transaction that the drone made directly into it and then burn the drone. But this was not implemented during the hackathon. Yeah, and now I'll give it back to Dan to talk more about the stack.
I mean, again, so since a full node has to run these three things, I mean, we were here since they just made the Tendermint branch, then we released 1.4 dev, then 2.0 alpha. This was exactly when we implemented it. It was fun. I mean, I do recommend following the BigchainDB GitHub. It's amazing. Like, you really have to track all the tags. Now it works. And on 2.0 Alpha 2 now, we actually have it stable. This is really important. The thing is, you really need Tendermint because you need the consensus, you need the access control, then you need BigChain for the literal, like, how do you query, how do you do this otherwise? You have to write it yourself, and it's horrible. Please use BigChain. And MongoDB now is no longer the distributed database that it used to be. Okay, so till that is resolved, Mongo, Okay, so Mongo used to be the distributed database that you would query. So you would have to query the entire replica set, which was one, and every node would sync with that. Now you do local queries. So Mongo itself doesn't know about all the other databases. It no longer cares. You have all the syncing is done through Tendermint, and you use the entire power of Mongo for your queries. I mean, this is for additional steps. We haven't implemented like Mongo querying yet. I also heard that there's work on the documentation on how to do that for now. So again, this is really powerful. It really helps us with a lot of things, and it is running. So again, it's just that small computer. It's the newest one that was released. It's the newest Raspberry Pi. But you have to swap the operating system from it because the default one, Raspbian, only runs on 32-bit, and Mongo doesn't like 32-bit operating system because, yeah, the length of the integer apparently for Mongo preferably is 64 byte. Byte or bits? Damn it, forget. Thank you. So yes, you need to swap it for a 64-bit compatible version. There's a lot of GitHub implementations of it. It's fine. Then you really try to run, you can run it yourself with the Docker. You just have to swap in the Docker Compose the MongoDB and the Tendermint from the BigChain ones to the ones we made. I mean, they're publicly available, hosted on Docker. And then you can run your own full node on ARM64 of BigChain because, again, Python just compiles everywhere. It's fine. And yeah, we put that on a drone. That is just a Parrot AR drone 2.0. It's fine. It was just working for us really well because they're on Wi-Fi. And if a drone is on Wi-Fi, we know exactly which drone to call. It has an IP address, so we send commands to that one. And yeah, the really cool part is implementing this with mesh Wi-Fi now. Because apparently it works. Latency was not that big of a problem. Swapping from a real like cable-based internet to a mesh Wi-Fi, it's fine. So now you can have all this entire network of drones communicate point to point, each to each other, but basically whichever one is closest to each other will get connected. And it seems to be working, so that's great. We finally got some space where we could actually fly them. It was horrible to find that in Amsterdam. It's a no-fly zone. I think, please work. Okay, perfect. So that one takes off, fine. All of them are running basically on 1 amp of power, which is really amazing. I didn't expect it to work. So it launches, it detects an object on that side. Because it just sends a transaction to itself, I mean, ORM transaction, it sends it to itself, and the other two are like, oh, we've noticed there's a new transaction sent from this drone regarding a new object. We have to go to this position. They go there, they align in that position, they land, that one got the confirmation of the land, and then it also landed. So all of this is based on transactions on BigChain. And all of this is, like, if one dies, it's absolutely fine. It doesn't matter. And this enables a very specific use case because if you're sending them in a very specific area where you expect some of them to die, you only need to retrieve one drone in order to get the full Mongo database. So actually, your retrieval costs of your entire project just rely on one drone. And this is it actually live running because we did implement a map. Not that one. And this is currently running on the one drone, on the one node from BigChain on the laptop because, again, this is a demo. It's almost hard to do. And now we have 5 simulated drones who are supposedly mapping an area right now. I think, is it up? Please pray to the demo gods. Yeah, so technically what you're supposed to see is a map with like static nodes, drones, and 5 which are currently running, and each of them is sending transactions about its current location. That is a lot of errors. Okay.
Just restart it.
Make reset, yes. Yes, please get familiar with that command if you're running the Docker. Make reset really helps a lot. Oh, Tendermint. Oh, nice. I mean, it was really fun working on 2.0, I have to say. With all its challenges, but getting it to run, oh my God, the satisfaction. And 5. Please load. Okay, never mind. So they are still sending transactions with background, which is the fun part. But the front end died. Okay. Well, we can all live with the front end dying. And yeah, sorry about that part. And in order to continue, Tobias is the CEO of CRUD, and he's going to... What happened there?
I think it's a network. We need internet.
Let me tell the rest of
Please,
the boring story. And then,
no, you can continue. We're just going to try maybe fixing it quickly.
you can switch to the presentation and then.
Yeah.
Oh, but then it cannot work.
Yep, okay.
So I'm going to do the boring part. I'm responsible for business and all sorts of stuff within our company. And because we really like the ID and we won the ID, we really want to take it to the next level. And also thanks to BigchainDB, we would like to develop a sort of infrastructure where multiple companies or multiple organizations can deploy use cases on top of the infrastructure. And what we would like to do, we would like to take this infrastructure to the next level. And that's actually what Dan is going to be doing in the upcoming months. And trying to see like what can we do from what we did on the hackathon to make it more stable and to make it easier to deploy. For example, what Dan now is currently developing is a Pi that everybody can buy with pre-installed stuff on it. We were actually wanted to take it here, but something.
The router broke. Sorry.
Yeah, something went wrong. But if you need it, if you need the code, just send us an email. Come up to us, and we will send it to you. And please put it on every single robot that you can. And then from a research perspective, because you can build use cases, you can build an infrastructure, but you also need research on this topic. And what we would really like to do, we are collaborating with the Dutch Aerospace Engineering Research Institute to see like how can we fit the regulation in this. Because if you look at certain areas, it would definitely add value if you have a swarm of drones flying to certain locations, and how can you do this? And those are parts that we really want to develop. And also with the universities, also with the Red Cross, and all sorts of other partners. And then if somebody has the budget to buy us a development drone from DJI, please come to us, because they're very expensive, but we really want to use them. We need 3, so that's what we need. And we're trying to reach out to DJI to let them get involved with our project, and to see if they are interested to actually take this on, and to see if they want to fund a couple of these drones. And use cases where you can think about mobility. So they're not drones then, but they're just cars that can share the same data, but there's already a lot of use cases in there. In Industry 4.0, having drones going to certain locations. Imagine yourself on Chernobyl, right? What if we had this system and you could really scout the system without sending people in there? It could have saved lives. Agriculture, going there, scanning the area, aerial imaging, and then taking the data, analyzing it, etc. And search and rescue for avalanches. That was actually a demo. Hopefully we can fix it and we can show it if you're interested. So that's basically how we see the future of this ID. And then I want to spend one more minute on what we do actually as a company. So basically when we started the company, we saw a problem. Is that a lot of these corporates, they're developing use cases and they think they have it right, but they don't understand the actual protocol, or they don't understand how it's actually working. So what we are doing, we're being a linking pin. We know the protocols, we work together with the protocols, so just like we work together with BigChain. And then we develop for these companies, we develop solutions. And what the strength in here is, if we see some stuff that in the protocol is not working, we bring it back to the community. And if we have new stuff which can implement in our solutions, then we bring it to the corporates. And I think from my perspective, this is really missing. And this is also really missing for corporates, this type of information and this type of approach. And this is what we're doing in mobility, supply chain, and industry. So for example, with KLM, we have been doing lots of cases regarding supply chain, where we use different stacks for them and explain them why different stacks were failing. Because every time IBM comes to them, they say Hyperledger, for example, it's a good stack, but it's not sometimes the best stack for the best fit for purpose. And that's what they need to know, and that's where we help them with. What we do for them, use case development, POC development, and we're now moving into implementation phases. And that's where we're very like a young group of people. And for the implementation parts, we're searching for partners. And because we don't have any deployment experience yet, but it's coming. So that was it.